All right, so our first question says the above graph shows the distribution speed of molecules in a sample at a certain temperature. What's going to happen if you raise or lower that temperature? So remember, the whole idea here is that all of the particles in a sample are not necessarily going to be going the same speed at the same time. And so that's why there is a distribution. Some of these guys here are slow, some of these guys here are fast, and that's kind of your average right there. So if you heat up a sample, then remember the particles are going to speed up. So if they speed up, then the maximum speed might be here. Well, if the maximum speed is right here, there's a wider distribution of the molecular speeds, and if there's a wider distribution, each individual speed has fewer of them. So for a hotter temperature, so that would be something that's like hot. A hotter temperature would be something like that, where it is wider, so a greater distribution of molecular speeds, but then fewer of them at each individual one. So there's fewer of them at each individual speed that is there. So that's what's going to be if it's hotter. Now, if it's colder, that means that it is slower. So your top speed is slower. Well, if your top speed is slower, right? So this guy here is there. So instead of that being your top speed has dropped down. Then there are fewer distributions of speed, and if there are fewer distributions, that means there is more at each individual spot, and so your distribution would look like this. So you have more at each individual speed, but then colder or slower top speed than it was before. So a cold situation looks like this. So here's what cold looks like, and then here's what hot looks like from there. So that is hot. This guy here is cold, right? So cold is fewer distributions, more at each speed. Hot is greater distribution, fewer at each speed.